we're group 2. I'm Lisa.
Oh, I'm Megan.
And we did the best damn pond. So this is a photo of our pond. It was located right behind the second trailer, as you can see up in the left corner there. The entry point for a pond where we usually go in is like the north side over here to do our samples. As you can see, it's pretty heavily wooded surrounding the pond with lots of big trees. You can also see that there's a big second pond located right behind it. When we were walking around it, we noticed that there's a little channel connecting the two ponds. Okay, so for our elevation survey, we took 3 points. A and C were pretty much the same height, and point B was less than half the height, probably because the two needs to be lower so that water can enter from the second pond. This is a bathymetric map of our pond. The innermost circle represents the deepest area, and it is marked at 200 centimeters. The deepest measurement we took was about 220 centimeters, so it's pretty deep. And then the shallowest line marks the 50 centimeter spot. Yeah, so our reference stake was located kind of on the eastern side there, and the water depth at that point was 105 centimeters, which was higher than it was last year, so the water level rose. Yeah, so the legend on here just explains where we took all of our samples. So, yeah, the A sample shows where we took the epiphyte and phytophyte samples, and etc. Our Secchi depth, the visibility was down to 151 centimeters, which is pretty deep because in that area of the pond there's about 175 centimeters. Also on this map, we marked where we had a little beaver lodge right here. So that's a picture of that. Also what we noticed when we were walking around the pond was we could actually see where the beaver was cutting down trees because they were, I don't know, all chopped up. So we have a video of our beaver. It's sideways though, and it's really, really short. So if everyone wants to turn their head this way. Oh wait, how do I do this?
This next.
I'll play it again. It's just him swimming and then flopping under the water. Yeah. Alright.
So here we just have a photo of us doing the procedure for the phosphorus concentration for our water and sediment samples. And we found the average phosphorus concentration for a water sample was just over 48 micrograms per liter, and for the sediment was just over 41 micrograms per liter. We think that the reason the water concentration is higher than the sediment was just because our pond had a lot of macrophytes in it, so all the plants in the pond were uptaking the phosphorus from the sediment, making the concentration lower. And that's just a picture of part of the procedure for finding the chlorophyll concentration. And for the chlorophyll concentration for our phytoplankton was 35 micrograms per liter, and for epiphyton was 895 micrograms per gram. And using the multimeter, we averaged all of our 6 readings we did, 3 different spots of the pond. And for our pH, we got 8.06. The conductivity was 2350, and the redox potential was 86.92. And we think that our conductivity was pretty high because it's connected to a second pond, and it receives more groundwater, which is higher in salinity, so it then increases the conductivity of our pond. And just pictures of us counting our samples. 2 live traps with amphipods in them. In our invertebrates collected, the majority of them were amphipods, copepods, mosquitoes, and damselfly, dragonfly, mayfly larvae. And the highest, I guess one of our samples, the highest number of amphipods we had in it was around 160, and the lowest number we had was around 80. Just forgot to mention that we only found one invertebrate in our funnel trap, and it was like one juvenile salamander.
Yes.
Yeah.
So emergent vegetation, we basically observed 3 main vegetations: cactus, phragmites, and bulrush. The most important observation, as you should see, is the cactus was 25 per meter squared in comparison to the bulrush, which was just 7.42, and phragmite is pretty less, 0.57. This region represents the most denser cactus we found. So around approximately, if I remember, was 12 13 cactus, 1/4 of the meter squared. So you're talking about 48 cactus a meter squared, which is a pretty good number. It was very dense, and the depth was pretty less, and I think this is one of the reasons we found lots of cactus there. Then for bulrush, 7.42, this region was the most densest. So the density for the bulrush at this region was about 8 to 9 bulrush, 1/4 of the meter square. So again, you're talking about 38, 36 bulrush per meter square, which is a good number in comparison to the average we have, which is just 7.42. The most important factor for as a team we observed was finding the exact and accurate watershed for our pond. As you can see in the picture, you can clearly see 4 different water bodies, out of which this is our pond, and there are 3 different similar ponds surrounding by us. So the most important factor working on a watershed, as we all learned, is we look for the highest elevation. So as you can see, it's more denser to go inside, and still the elevation is going up. So what we observed is elevation surrounds somewhere right over here. So for last year, the yellow line, the red line represents the watershed for the last year. So as you can see, they sort of followed a path of convenience than of accuracy. So they, being honest to you, we got on the same track. We went there and we figured out there is a man-made path already made. So this is what they did last year. What I think, not blaming them, but I think this is what they did. So they just followed a convenience path, finished their project on time, and studied for their final exam. And for this year, what I think, this is the more accurate one, because we went more dense inside the watershed region of the forest areas, and we, instead of coming just out from the inside region, we followed the whole exit till the road ends, and then we went back in. So I think this is more accurate, but it can be much better. Again, as you can see, the density of the forest still getting inside and inside, and it looks, if you see the past, I'm not sure, about like 200 years ago or 100 years ago, there are chances these all the ponds was one pond altogether, and this all region was just a watershed as common. But after a few years, things dried up for some reasons, so 4 separate ponds was created. I think this is one of the reasons. So as you can see, many of you had their GPS tracking mapping, and I observed personally that you mostly followed like this kind of region. But for ours, it's like more of 3 times the pond's actual surface area than the actual watershed surface area in comparison. Also, I would also mention one thing I observed by the ring toss experiment we done for the submerged vegetation. The first thing I observed doing that was, it was pretty easy because it's just yes and no. So we took lots of samples, and I was figuring out what output we can get exactly, by doing this, by knowing there is vegetation or not vegetation. But at the end of the day, when we plotted all the data, I figured out one thing. Actually, Lisa mentioned this to me, that there is, the green circle actually shows the vegetation, and the red shows that there is no vegetation. So Lisa mentioned to me why we still have yes and no's till the pretty deep end of the shores. So I think one reason we concluded as a team was, the reason we still have vegetation on that side of the pond is because the depth is pretty less. So you can see the belt region, the belt is just, this whole belt is just 75 centimeters in deep, and whereas if you see other side, this rings start falling up this region, so the density and the depth of the pond goes more and more pretty close to the shores. So that side of the pond is less denser or less depth in comparison to the other circle rings. So one more time again, as you can see, this region, the green vegetation stops after some distance, whereas there it's keep continuing, and even at this region, we observe there is less depth. That's the region we have yes and no's still pretty deep and from the shores. Also, I would love to mention as a team to Justin for helping us out with all the experiment. Not just because he was our TA, and because he was always there and looking out for us with his eyes. If you guys have any questions, we would love to